We have another example. Limit of the rational function. In other words, we have again fraction. We have to start solving this problem from looking at the denominator. Replace x by 3 and check what we are going to have in the denominator. We have 2 times 3 is 6, minus 6 gives me 0. Keep in mind, we cannot have 0 in the denominator. We never divide by 0. So what I'm supposed to do next? I'm supposed to look at the numerator and I'll try to factorize the polynomial which I have in the numerator. So let's take a look what we have. I have limit with x approaching 3, and in the numerator I'm going to have x minus 3, x minus 1. I can factorize this polynomial. Again, if you have difficulties with factorizing, you don't understand what I'm doing, you're supposed to review algebra factoring. Next, please notice that in the numerator I have term x minus 3. In the denominator I have 2x minus 6. I can find a common factor for 2 and 6, which is 2, and factorize it. And I'm going to have 2 at the front of the parentheses, and in the parentheses I'm going to have x minus 3. I factorize 2 from the denominator. I have x minus 3 and I have x minus 3. I have multiplication, that's why I can do reducing. I'm going to reduce this one and this term. And I end up with limit x is approaching 3 of x minus 1 over 2. Please notice that this time my denominator is never going to be 0. So what I'm supposed to do next? I'm supposed to simply replace x by 3. And I'm going to have 3 minus 1 over 2. 3 minus 1 is equal 2. 2 divided by 2 is equal 1. This is the solution to my problem. Let's take a look at this example. We have limit of the rational function where in the numerator I have polynomial with 3 terms and in the denominator I have also polynomial with 3 terms. The concept is exactly the same. First, you have to always look at the denominator. Replace every single x, in this case by 4, and check what value I'm going to have in the denominator. 4 to the second power is equal to 16, minus 2 times 4 is 8. 16 minus 8 is 8. 8 minus 8 gives me 0. Keep in mind, we do not want to have 0 in the denominator at any time. So just look next at the numerator and check what we can factorize, and in this case we have to also look at the denominator, and we're supposed to factorize this denominator and check what we can reduce. We can rewrite this problem as limit x approaching to 4, and if you are going to factorize the numerator, you are going to have x minus 5 and x minus 4 over x minus 4, and I have x plus 2. This is the expression of my problem after factorization. I factorize numerator and denominator of my rational function. The common factor for the numerator and denominator is x minus 4. That's why I can cancel them out. And take a look what I'm going to have next. I have limit with x approaching 4, and in the numerator I have x minus 5 and I have x plus 2. Again, I end up with the rational function. I have to check the denominator. X is approaching 4. 4 plus 2 gives me 6. 6 is okay because we have to make sure that we are never going to have 0 in the denominator. So when the denominator is not going to be 0, I can simply replace every single x by 4 and I'm going to get the answer to my problem. I have 4 minus 5 over 4 plus 2. 4 minus 5 is equal negative 1 over 4 plus 2 is equal 6. Is equal negative 1 over 6. And this is the solution to my problem.